Differential equations, we're looking at the 4.1 through 4.3 second review sheet. This is pretty much exactly what your summative is going to look like. It's going to have the same basic problems. You will start with something like question 1, where it says for each set of functions, set up and find the Wronskian and determine if the set is linearly independent or linearly dependent. Guys, they're giving you three different solutions here. You've got y equals 5. You've got y equals sine squared of x, but tell you what, I'm going to write it the way we'd have to type it into the calculator anyway, like sine of x, quantity squared. And then we'll also write that as the cosine of x, quantity squared. Y prime of 5 is 0, and then y double prime, of course, would also be a 0. Y prime here, we'd get 2 sine of x times, well, now we'd need to do the chain rule. The derivative of sine is going to be the cosine of x. And then what? Well, as we take a second derivative, we're going to need a product rule, aren't we? We'll have 2 sine of x times the derivative of cosine, which is negative sine of x. And then we'll take the derivative of 2 sine of x, which is going to be 2 cosine of x, times the cosine of x. So in other words, what we'll really have is a negative 2 sine of x squared. And then we'll have a 2 cosine of x squared. Very similarly, when we come over here with y prime, we'll have 2 times the cosine of x, but then we have to multiply by the derivative of the inside, which is going to be negative sine of x. So our y prime here is really negative 2 cosine of x sine of x. But then, like our last problem, we're going to have to really set up a product rule. We'll have our first negative 2 cosine of x. The derivative of sine of x is cosine of x. And then we'll say plus, well, then we're going to have to take the derivative of this negative 2 cosine of x, which will be a positive 2 sine of x. And what are we going to be left with? Well, a negative 2 cosine of x squared. And here we'd have a 2 sine of x squared. And I know it's tempting to write it in the shorthand way, just putting the 2 as if it were elevated above the n, and you may certainly do that. But, we're a little bit jammed up in here with our work. I just wanted to show all this. Let's just go off to the side and show what the Wronskian would really be. The Wronskian, well, for your y's, you've got the 5, the sine of x squared, and then the cosine of x squared. And then you're going to go ahead and take your derivatives. Well, that's a 0. Here we'd get 2 sine of x times cosine of x. And then over here, we'd get negative 2 cosine of x sine of x. Of course, you could have put sine of x out in front. And then how about for our second derivative? Well, down here we get a 0. And then, this second derivative will have a negative 2 sine of x squared. And then we'll say plus 2 cosine of x squared. And you know what? I think I'm going to actually use my lasso over here and maybe just slide that over just a smidge. Always nice when you can do that on this program. And then down here we'll have negative 2 cosine of x squared plus 2 sine of x squared. And guys, that's really what we've got for our Wronskian. Now, this is where you want to use your TI-89. And the TI-89, you're going to go to the determinant. That's with the catalog. And search for D. And the parentheses right above the 7. Then if you go right above the 9, there is a comma, but if you hit second comma, you'll get a bracket. Then you can say 5. Again, your comma is right above the 9. And we can type in the sine of x, and then say squared, say comma, and then we'll say parentheses cosine of x squared. But then, of course, you need a semicolon. And that semicolon, if you go to the 9 button, look right above it, there is the semicolon when you go second 9. And that's how you get that to show up. And then you'd say 0. You know, again, we're just entering in this row right now. And we can say 2 sine of x, cosine of x. And then we'll hit -2 cosine of x, sine of x. Then what? Then we'll hit our semicolon, 0, comma, and now is where we just have to write that second derivative. -2 times the sine of x, whole thing squared, plus 2 cosine of x, whole thing squared. And one last one, I'm talking about this right here, where we'll go -2 cosine squared plus a 2 sine squared. Now, of course, what you need to do here is then close your bracket. That's going to be right above the division sign when you hit second the divide. And then you've got to close your parentheses. Now, this whole big determinant is going to equal 0. So what that really means is we're going to have linearly dependent solutions. Because our Wronskian was equal to 0. Definitely you may use your TI-89 to get assistance with that. I think the next problem is at least a little bit easier. I hope you're going to find it to be a little bit easier to type in, especially. You've got y equals 1 plus x, you've got y equals x, you've got y equals x squared. Y prime is just a 1, y prime here is just a 1, y prime here is a 2x, y double prime is going to equal a 0, y double prime here is a 0, y double prime would equal a 2. So what is our Wronskian going to equal? Well, we have a 1 plus x, an x squared, a 1, 1, and a 2x, a 0, 0, and a 2. So what you have to type into your TI-89 is the determinant, and that left parenthesis shows up. Get that bracket, the left bracket, by hitting second comma. The comma is right above the 9. We'll go 1 plus x. Again, the comma is right above the 9. X squared. But then we need a semicolon. Go second 9 for the semicolon. Then we'll go 1, 2x. We need another semicolon, second 9. Finally, we'll have 0, 0, 2. Close your bracket. The bracket is second divide. Close your right parenthesis. That's right above the 8. This thing, if you work it out, you should see that you will get a 2. And because that's not equal to 0, you can say that we have linearly independent solutions. So I'm going to end this video here and pick up with problem 2.